Hello everybody and welcome to this new video. Today I'll be teaching you about multiplexer. I already covered these, especially that one right behind me. There's not a lot of difference for the moment, but we'll get to that in a minute. And some other videos, but they were never really the main focus of it, so I wanted to make a separate video for them, so I don't have to re-explain them every time we need to use them, because you need to use them quite often. So without further ado, let's get right into it. So what is a multiplexer? Well, to illustrate the idea, I'll sketch a little situation. Imagine you have two components in your computer and they're quite far apart, but you need to transmit data between them. Let's just say the first component has 16 outputs that have to run in the 16 inputs of the other components. Well, what you could do is just run those 16 lines through the computer, but that's not really space efficient. So what we could do is place them in binary, convert them into binary. Then you only need 4 lines, and that's a lot easier. That's basically what binary is. It's just a way to compress data. Our decimal system is also just a way to compress data. If you, for example, had to write 2 million, you could write it uh, in, in our decimal system, but you could also write 2 million stripes. That would be not very space efficient and would take a lot of time to write down, so we don't do that. Binary is just the same, but decimal is even a little bit better at this. Well, you have two different components, one to code the data and one to decode it at the other end. This one is to code it, which is much easier, and this one is to decode it. That one is quite a lot harder, not too hard, but we've seen that one a lot more. Let's start with this one. I forgot to place the repeaters, don't forget that. For this one it's not necessary, you'll see in a moment, but don't forget to place your repeaters. Anyway, how do you make sure that this codes this into binary? Well, you have 16 different lines, all representing the different binary numbers from 0 up to 15, and these will be your inputs, and of course these will be your outputs. Well, you just take redstone torches and place them where all the ones need to go. What this will do is, what this will do for the moment is just power all of the lines, because all of those redstone torches are activated. But in a moment, what we will do is activate all of the lines from where the redstone torches run on top of, and what this will do is deactivate all the redstone torches, and none of these lines will be active. But if we, for example, deactivate this line, then all of the other lines are active, which makes sure that none of the redstone torches go on, and they don't interfere with the line that needs to be active. So, for example, this one goes from active to non-active, and these redstone torches will go on, powering the lines that need to be powered to represent that number. In this case, that is 5. So let me just place these torches real quick. Almost done. I think I got all of them. Pretty sure. Yep. So what we need to do next is make sure that we invert it. That's just a matter of placing a redstone torch, a simple NOT gate. You should know what a NOT gate is by now. If you don't, check out the logic gates video. stack 15, and believe it or not, but we're actually already done. Let's space that one a little bit apart. I don't know if that redstone torch will power it, but either way, I don't want it to. So let's do that for safety. And for example, now none of the lines are powered, so we would expect 0, 0, 0, 0. But if we, for example, want this line as output, so that's number 1. We activate that, and what is it? What hasn't? Oh, I have to again place repeaters. Didn't reach far enough, and now you see this redstone lamp is on, and this is the binary number for 1. Or another example for, what is this one? I think this is 10, no 12, I think. No, 10, 10, so this is the binary number for 10. And like I said, this one is really easy. You don't need to invert the lines here, but you need to invert the lines at the input. Note, this only works when there is one output that needs to be active. If you need 2 outputs that are active, then you will have no choice but run all the 16 lines, or you can do something clever. But this system will only work for 1 output. This one, to decode the numbers, is a little bit more complicated, but we've seen this one more often. You see, for the moment, all of the redstone lamps are on. Don't worry about that, the system is far from done. So, the trick that we'll be using here is, instead of powering the line that needs to be powered, we'll be powering all of the lines, except one, the one that needs to be powered. And then we just invert it, a simple NOT gate, like you see here, all lines, and you get your output. It's a lot easier to power all of the lines that don't need to be powered than the reverse. So how do we do that? Well, for where all zeros are, before that, we go a little bit down, 1 block down, and we put a repeater there. What will happen now is, if this line is off, so it gets an input, and the input says that this line is off. Well, this repeater will not power, and it will not power this line. What this means is that, according to this line, because it is not powered, it could be that the number that the component gave us as an output in the previous over there could be this number, because for it to be that number, that line needs to be 0. So it could be possible. But for example, if this one would be a 1, now yet it doesn't work, then it wouldn't do that, because it wouldn't be that one, because here we also have to place a repeater, and now this repeater powers this line, saying it can't be this line. So then it goes to this NOT gate, inverting the signal, and the redstone signal goes off. For the white ones, where it needs to be a 1, we place a redstone torch like we did over there. So for example, here it needs to be a redstone torch. Let's place a redstone torch over there. So now this line isn't powered, powering this redstone torch, and I mean, because this isn't powered, this redstone torch is still powered, that's what I mean. This redstone torch powers this line, saying it can't be this one, because if it was this one, this line would need to be a 1, and it isn't. But if we turn this upside, oh, that was a little bit weird. If we turn this to a 1, it depowers this redstone torch, and this line isn't active anymore, saying it can be this one. And now it's just a matter of placing them everywhere. And I'm done. As you see, now it's set to 0000, and this is the output that we would be expecting. For example, let's set this to 7, and you have 0, 1, 2, 3, 4, 5, 6, 7. Perfect. So this works like a charm, and it is actually ready for use. I did this with World Edit, thank God I have that. Again, if you build Redstone computers, I highly recommend downloading World Edit. It's so much easier. Okay, and now notice how in this component there is no NOT gate at the input, but there is one at the output. And here it is inverted. At the input there is a NOT gate, but not at the output. So don't swap those around. In some rare cases, you actually use them immediately after each other, and one of those is in previous week's episode about the what was number display unit. Always go also to go check that out. 2 parts, but where I built this, that was the second part. Anyway, this is looks should look very very what's the word? Okay, I forgot. Doesn't matter. But it should look like this. And this one is just a variant of this. I mean, that one looked like that, I'm sorry. And this one is just a variant of this, but stacked on top of each other. So there are two. Why there are two and everything, again, go check out that other video. It's not exactly the same, but close enough. And what this does is, because we first begin with that one, which at the output has a NOT gate, and this one has at the input a NOT gate. Two NOT gates cancels each other out, and we can get rid of that NOT gate, and it's just a straight line. So if you use them immediately after each other, you can get rid of both those NOT gates. And I think that should be everything. Again, these are components that you use regularly in your Redstone computer to code and decode data. Also, quick thing not yet, I extended these lines because otherwise the redstone torches won't reach this one. Remember, this redstone torch doesn't power this line, only this one. But anyway, I hope you enjoyed it. I hope you learned something from it. And if you did, please consider subscribing and liking. It would really, really, really make my day. I hope you have a good day, and bye!